You survived the floods. You survived the ice. You survived 55 consecutive wet days, frozen pipes, and a winter that refused to leave. And then, just as March arrived and you finally started to breathe again, spring did something that nobody was fully prepared for. It did not arrive slowly. It arrived like a door slamming open, and the shift it triggered is shaking meteorologists, farmers, and scientists across the entire country. What is happening to British spring right now is not normal, and the evidence is impossible to ignore. Let us start with what the country actually lived through in winter 2025 into 2026. It was not an ordinary bad winter. It was one of the most meteorologically unusual seasons in modern UK records. The jet stream, the fast-moving river of air, high in the atmosphere that drives almost all of Britain's weather, sat anchored directly across the south of the country for weeks on end. That position created a conveyor belt, pulling storm after storm straight off the northern Atlantic and piling them onto the British Isles with relentless, grinding consistency. Cardinham and Cornwall endured 55 consecutive wet days before finally recording a dry day on the 24th of February 2026. 55 days? That figure is not a misprint. Dorset and Cornwall recorded their second wettest winter since records began. Parts of South Wales were hit with severe flooding as saturated ground, already holding more water than it could manage, failed to absorb even moderate rainfall. Gusts exceeding 99 miles per hour were recorded at coastal locations, among the strongest in decades. Aberdeen went weeks without seeing the sun, from the 21st of January until the 12th of February, without a single meaningful break in the cloud. Met Office data confirmed that mean temperatures across the UK were above the seasonal long-term average for winter overall, despite the brutal cold snap in January. A warmer atmosphere holds around 7% more moisture for every degree Celsius of warming, so when it finally rains, it does not just rain, it pours in a way that older infrastructure, older drainage systems, and older planning assumptions were simply never built to handle. Then March arrived, and everything changed at once. The jet stream, which had been running powerfully below the UK all winter, began to weaken and shift. By the middle of March, it had reformed into what meteorologists call an omega blocking pattern, a shape where the jet stream bends into a wide arc above the country rather than pushing across it. When that happens, low-pressure systems that would normally sweep through and bring rain instead stall out over the Atlantic, cut off from their driving force. High pressure builds over and around the UK. The wind drops, the skies clear, and the temperature swings in a direction that, after months of gray, relentless rain, feels almost surreal. By early April 2026, the Met Office was issuing forecasts for temperatures reaching 26 degrees Celsius in central and southeast England. Met Office chief forecaster Paul Gunderson described it as a brief but notable spell of very warm weather, with temperatures more typically associated with late spring or early summer arriving in the first week of April. For many parts of the country, these values were more than 10 degrees above the early April average. Communities that had been sandbagging doors and watching rivers in February were now sitting in their gardens in shirt sleeves. But here is where the crisis begins. Because this is not just a pleasant surprise after a difficult winter. This swing, this violent lurch from one extreme to the other in the space of a matter of weeks, has a name. Scientists call it climate whiplash, and they are warning that it is becoming one of the most serious and least understood consequences of a warming climate in the United Kingdom. Climate whiplash describes the increasingly rapid swings between one type of weather extreme and another, dry to wet, wet to dry, frozen to warm, flooded to baked. The pattern is not new, but research published in early 2026 confirms that shorter-term whiplashes, occurring over just a few months, have become roughly a third to two-thirds more frequent globally over recent decades. Year-to-year swings have increased by up to a third, and in the UK and Europe, the jet stream is the primary driver of all of it. The consequences of this whiplash are not just uncomfortable, they are seriously damaging to the infrastructure, the economy, and the food supply that the country depends on. Consider what happens to the ground. After the wettest winter many regions have experienced in living memory, soils across large parts of England and Wales entered spring in a state of deep, prolonged saturation. Rivers were already running high, reservoirs were full to capacity, drainage systems were at their limit. When the sudden warmth of April arrived and evaporation began pulling moisture upward from the surface, the soil started drying from the top down, but the deeper layers remained waterlogged. Now, as dry conditions stretch through April and into the early weeks of May, the Environment Agency is already flagging the possibility of a flash drought, a sudden combination of very low rainfall and hot temperatures that can emerge with almost no warning after a wet period. The same fields that were underwater in February could be cracking and dust dry by June. For British farmers, this is not a theoretical concern. It is a crisis playing out in real time across the agricultural calendar. Fields that were too waterlogged to plant on schedule in winter are now drying out faster than anticipated under April warmth and the Omega Block's persistent dry conditions. The spring growth window, already compressed by the late start, is now being further squeezed by conditions swinging unpredictably between extremes. Crop varieties selected for average seasonal conditions are under stress. Planting schedules built around averages that no longer exist are becoming increasingly unreliable. The jet stream behavior adding fuel to this spring crisis is genuinely unusual, even by recent standards. Multiple sudden stratospheric warming events occurred during winter 2025 into 2026, disrupting the polar vortex and influencing atmospheric pressure patterns at altitude. A further sudden stratospheric warming event occurred in early April 2026, described by meteorologists as a very late event by all accounts. These events have pushed the jet stream into a weak, severely undulating pattern that long-range models from both GFS and ECMWF are tracking with unusual consistency. Both major forecasting systems are currently showing no significant change to the shape or position of the jet stream extending right to the beginning of May. What that means practically is that the omega blocking pattern responsible for the dry, warm spell now gripping much of England could persist for weeks longer than a typical settled April spell. The ground continues to dry. Reservoirs that were overfull are beginning to drop. River levels that were dangerously high are falling, but the underlying infrastructure damaged by months of flooding has not had time to be repaired or assessed. And communities that spent winter managing excess water must now prepare for the possibility of managing a shortage of it. The same La Niña event that contributed to the jet stream positioning throughout winter 2025 into 2026 is now officially weakening. NOAA and the ECMWF are both tracking a transition toward ENSO neutral conditions, with a new El Niño pattern potentially emerging as early as May 2026 and building through the summer. If that transition occurs on the timeline current models suggest, it adds another layer of volatility to the weather pattern heading into late spring and summer. Climate scientists note that El Niño transitions have historically been associated with elevated temperatures across the UK in summer months, with a pattern that, in some cases, follows directly on from the cold and wet of a La Niña winter. Early indications from seasonal models suggest that summer 2026 in the UK will likely see slightly drier than average conditions in early summer, with an increased risk of extreme heat. After a winter of record rainfall and a spring of violent weather swings, the prospect of a hot, dry summer is not simply a forecast. It is the next chapter of a climate story that the UK is living through right now in real time. The Climate Change Committee, the independent body tasked with assessing how climate change affects the UK, is due to publish its next major risk assessment later in 2026. It will arrive after one of the most extreme 12-month weather sequences the country has recorded. Policy experts and climate scientists alike are pointing out that the systems currently in place, the insurance frameworks, the infrastructure standards, the flood planning models, the agricultural support structures, were all designed around averages. But the UK is no longer experiencing average years. It is experiencing a relentless sequence of extremes that are arriving faster, shifting more abruptly, and demanding responses that the current system was never built to deliver. Spring used to arrive gradually in Britain. It used to give the land time to adjust, the farmers time to plan, the rivers time to settle, and the people time to breathe between one season and the next. What is happening now is different. Spring 2026 did not arrive. It erupted. And what comes next in the months ahead will depend not just on the jet stream or the El Niño signal or the state of the polar vortex, but on whether the people and institutions responsible for managing this country's response to weather are willing to accept that the old playbook no longer applies. The ground is still wet underneath, the skies are clear and warm above, and the gap between those two realities is where the next crisis is quietly building. There's one more dimension to this story that deserves serious attention, because the impact of this spring whiplash is not only being felt on farms and in floodplains, it is being felt in the natural world in ways that have consequences stretching far beyond this single season. Phenology is the scientific study of the timing of natural events, the first blossom on a tree, the first egg in a bird's nest, the first emergence of a pollinating insect. These timings are the product of millions of years of evolution, calibrated to the specific rhythm of the seasons. When that rhythm is disrupted, the consequences ripple through entire ecosystems in ways that are difficult to predict and even harder to reverse. A sudden warm spell in early April triggers trees to blossom ahead of schedule. Insects begin to emerge earlier than their historical patterns. But if a cold snap returns in late April, which long-range models are not ruling out, those blossoms can be destroyed by frost before pollination is complete. Birds whose breeding cycles are timed to the peak availability of those insects find themselves out of sync with their food supply at the most critical moment of their reproductive year. This is not a theoretical problem. It is already being documented by ecologists and naturalists across Britain. Spring 2025 was provisionally the warmest and sunniest on record for the UK, with temperatures running 1.44 degrees Celsius above the long-term average. After that record-breaking warmth, winter 2026 delivered one of the wettest and most disrupted cold seasons in recent memory. And now, spring 2026 is oscillating between warmth that feels like June and the persistent risk of late frosts across inland and valley areas. Each swing adds stress to systems that are already under pressure from a decade and a half of above-average seasons. The State of the UK Climate Report published for 2024 confirmed that the UK's climate has become steadily wetter since the 1980s, with the increase concentrated in winter rainfall from October through March. Climate projections now suggest that UK winters by 2070 will be up to 30% wetter compared to those of 1990. That is not a distant projection. It is a direction of travel that is already clearly visible in the data collected over the past decade. And the winter of 2025 into 2026 represents one of the clearest single-season confirmations of that trend the country has yet recorded. What makes the spring crisis so significant is precisely that it sits at the intersection of all of these converging pressures. A record wet winter leaving the ground saturated, a sudden atmospheric shift producing near-summer warmth weeks ahead of schedule, a jet stream locked in an unusual blocking pattern with no clear signal of when it will revert, a transition building in the Pacific that could reshape summer weather across the northern hemisphere, and a policy and infrastructure framework that was built for a climate that no longer exists. The warning is not written in a forecast model or a scientific paper alone. It is written in the cracked fields of Cornwall, the still swollen rivers of Wales, and the frost warnings being issued for April nights that should feel like mild spring evenings. Britain's seasons are not just changing, they are fragmenting, and the sooner that reality is acknowledged honestly, the better prepared this country will be for what comes next.